All right, let's try a geometric proof here. And we're given that AC is equal to BD. All right, we want to prove that AB equals CD. So whenever we're given something, we're usually also given a picture. Usually, if we're not, we can make our own. But in this case, we are. So here it says that we're given AC equals BD. We want to mark up the picture as much as we can accurately. All right, so if AC equals BD, that means that AC and BD, those are the same, and I'm just going to add these above here and put tick marks to show they're the same. Okay, we can maybe see that, but sometimes visually it helps. We're trying to prove this. Remember, like I said before, that what we're given are these freebie spots, right? We can always put given in there as the first reason. And what we want to prove, they fill it in for us, but what we want to prove always goes in the bottom statement. All right, and then they also fill out these statements for us. So we just have to come up with the reasons. So it shouldn't be too bad. Let's try it here. First thing that they do is they say AC, right? AC equals AB plus BC. So it's made up of these two parts. All right, also included in this number 2 is that BD equals BC plus CD. Okay, so because those two smaller parts are added together to get the whole, remember that's called segment addition. So the reason, we can say segment addition. Segment addition postulator is segment addition. All right, then what do they do now? We have AB plus BC equals BC plus CD. So a lot of times, to go from one step to the next, they just change one small thing. Or in this case, it's a little bit harder to see, but I am seeing that AB and BC, that's here, right? I'll use little squiggly lines for that one. And then BC and CD, that's here. Well, how do they set those equal to each other? Aren't they equal to AC and BD? Well, if we remember back from step 1, going back one more, that here we know that AC is already equal to BD. So if those two are equal to each other, then I can of course set these two equal to each other. And by doing that, if we take one and put it up in here, that's called substitution. Substitution. Okay, it's a little bit tricky to get there, but hopefully you kind of see that we're replacing one of those. All right, and then the last step says that AB equals CD. And again, what did we do? Let me erase some of these so we can see what happened from our last step to this step. And we have an AB and we have a CD. I'll do a double underline for AB. That was up here. CD is now over here. All right, and then both these sides, here we go, both these sides have BCs on them. So what if I subtract BC on both, and those cancel? That would leave me with AB equals CD. So what do I do to get to this step? I use the subtraction property of equality. Okay, and did I get what I wanted to prove? I sure did. So therefore, this proof is done.